Hello everybody, this is the Unit 10 review video going over elasticity in this first video, and then we'll hit consumer surplus, producer surplus, deadweight loss, and government revenue in the second one based on different graphs. So let's jump right in. All right, so talking about demand elasticity, right? Demand elasticity is simply the sensitivity of the quantity demanded to changes in price. So something that's highly elastic is going to change dramatically. A slight increase in price results in a dramatic decrease in quantity demanded because consumers like you and me are very sensitive to those changes in price. Something that's highly inelastic, it doesn't matter how much the price changes, the quantity demanded doesn't change all that much because we're not really worried about price. So what are the characteristics of these? Characteristics of something that is highly elastic means that there are a ton of substitutes, right? I can get this, or I could get something else, or something else, or something else. So when the price rises for one good, I just say, you know what, don't worry about that. I'm not paying that higher price. I'll just go over here to something else, right? It's also something is highly elastic if you have a lot of time to make a decision, right? So it doesn't have to be made now, but it can be made in the future. So I can wait for the best price. So quantity demanded changes significantly for that. Another one is if it's a large portion of your income, it's more likely to be highly elastic because you're waiting for the best possible price because it's still going to hurt you quite a bit in the little checking account. All right, so that's elasticity. Something that's inelastic, a couple of characteristics are kind of the opposite of that. There are very few substitutes, or it's a need, right? Elastic goods are more likely to be a luxury, but inelastic, it's a need. I have to have it. It's a very small portion of your income, so changes in price don't really weigh that much into it. Like sometimes 25 cents goes up to 30 cents. That's not that big of a deal, so I'm not going to change how much I buy when it's a very small portion of my income. Something that's highly inelastic has, like I said, very few substitutes. So gasoline is a great example of this. If I don't get gas, I have very little else I can do to make my car run. So that's going to be highly inelastic. What they look like graphically is over here. A flat curve is highly elastic, as we can see here, right? A slight change in price of P going from P1 to P2, slightly increasing, results in a larger increase or decrease in demand. So demand goes from Q1 to Q2, a larger decrease in demand when a slight increase in price, meaning that we're sensitive to it. Price went up, we're like, you know what? I'm just going to sub this out for something else. Something inelastic graph is right here. As we can see, it's very steep, because it takes a dramatic change in price, right, from P1 to P2, increase quite a bit. There's a very small decrease in quantity demanded, right, very small decrease. This is because it's something that I need, right? Sure, gasoline going up to $3.50 a gallon is trying and it hurts, and I might try to decrease the amount of driving I'm doing, but generally it's only going to be a slight decrease in quantity because I still need gasoline to get to where I'm going. So that's highly inelastic there. So easy way to think of this is, when it's steep, it's getting closer to being an I, kind of an italicized I, so it's inelastic, and the other one is elastic. So that might make it a little bit easier for you. Probably the most challenging part of this is calculating the coefficient. So let's try that out. The demand elasticity coefficient is the percentage change in quantity over the percentage change in price. You should know that equation for this test. And sometimes the percentages are given to you, sometimes they aren't. Make sure you're not doing a quantity change, but you're doing a percentage change. How do I identify a percentage? It's simply current minus previous divided by previous. So let's try one out. Okay, so we see here the price changed from $5 to $10, went up by $5, right? So current is always going to be the second one, the B. So current is 10 minus the previous, which is 5. Gives me 5, the difference, right? And then I take that 5 and I divide it by my previous, right? So my previous was 5. So 5 divided by 5 is 1, or 100%. We had a 100% increase here. We doubled it up, right? So 1 is that change. Okay, so that's going to go on the bottom here, 1. On the top is going to be 75, which is our current, minus previous, which is 100. So it's going to be a 25 different. Remember, we're working with absolute values on demand. We don't care about positive or negative. So we're just going to call it 25. 25 divided by 100 is 25%, or 0.25. We plug that into our equation here. We have 0.25 divided by 1, which is going to kick out a 0.25 demand coefficient. And that means it's less than 1 or it's highly inelastic. And sometimes they'll give you this and they'll ask a question like, is this elastic or inelastic? You can figure it out pretty easily. Say, whoa, that's a big change in price. That's a slight change in quantity. That's probably going to look like this one, where a big change in price results in a slight change in quantity. It's insensitive to a change in price. It's probably inelastic. Once you calculate the coefficient, just remember if it's greater than 1, it means that the quantity is changing at a greater rate than the price, which means it's elastic, right? Quantity is highly sensitive, like this one here, highly sensitive to a change in price. This number is going to be bigger than this number, or at least this percentage number is going to be bigger than this percentage number. So it must be elastic. If it's less than 1, the opposite is true, and it's inelastic. If it's 1, it's unit elastic, which is a 45-degree angled demand curve here, where the percent change in price and quantity are the same. Okay, and then finally, infinity is perfectly elastic, and we'll show you what that looks like in a second, and 0 is perfectly inelastic. Those are not nearly as important as the other ones. Okay, let's look at a little chart here that might help with this. Here it's showing how you do the percent change, right? So instead of plugging in the percentage, which you could do, I plug in the decimals here. So 0.1 divided by 0.25 kicks out 0.4. 0.4 is less than 1, so it must be inelastic. Then it talks about how gasoline is inelastic because it's a need. Even though the price changes all the time, the quantity demanded doesn't change all that much. And then here you see different slopes of the demand curve. The more vertical it is, the more inelastic it is. And then as it goes down, it's getting more and more elastic, right? So it goes from highly or perfectly inelastic to mildly to very to very to mildly to unit elastic, or basically a wash. All right. One more chart. I think this is a good chart to use when we're talking about elasticity is right here. So this is on the slides, but it's here as well. So you can look over this and memorize it. Mainly understand what it looks like, understanding your coefficients and your types of elasticity. If you know those things, you're going to be in pretty good shape on these, right? Most of the time, you're going to look at a graph and have to determine if it's elastic or inelastic. We're going to have to calculate a coefficient and then figure out if it's elastic or inelastic. All right, now sometimes it's still very difficult to figure out if something's elastic or inelastic. If that's the case, just looking at it, then you can implement something called the total revenue test. Total revenue test is just checking out what happens to total revenue. It's pretty simple. Total revenue is price times quantity. So here at point A, my total revenue is 2 times 10, or my total revenue is 20, represented by this yellow box here, 2 times 10 or 20, right? And then down here, my total revenue on B is 40 times 1, or 40. 40 is my total revenue there. So it's price times quantity, very simple equation represented by the boxes there. Now, if price goes up and total revenue goes up, or when price goes down, total revenue goes down, we're looking at an inelastic good, meaning when I change the price downward, when I decrease the price, I'm just taking profits out of my own pocket because decreasing the price does not result in more people buying my product, right? But when I increase the price, then the same amount of people are buying it, so the quantity is relatively the same, price goes up, total revenue is going to rise. So it's inelastic, or vice versa. If price goes up and total revenue goes down, right? If when I increase the price, I lose money, then it's elastic. And vice versa. If I decrease the price and I gain money, it's elastic. People are sensitive to that change in price. This is a reason elastic goods are always on sale, but you'll never see an inelastic good like gasoline go on sale, right? Because when the price goes down, they just lose money. Why would I put a sale on that? Right? But when price goes down for other goods, they could gain money, increase their total revenue if they're elastic, and so the sale would be preferable. All right, so let's check it out over here. Is this elastic or inelastic? Well, you already know it's elastic just looking at it because it's pretty flat, right? The slope is down there. Clearly, the percent change in price is much lower than the percent change in quantity, right? Going from 1 to 2 and then going from 10 to 40, much larger. So it's elastic, but let's try the total revenue test. Okay, so let me grab my little pen here. So at A, my total revenue is 2 times 10, or 20. Okay, and then price goes down. So if quantity goes down with it, then we have inelastic. If total revenue goes up with it, then we have elastic. So let's check it out. So we went from 2 to 1. we went from 20 to now 1 times 40, right? Price times quantity, 1 times 40 at point B, so we went up to 40. Price went down, total revenue went up. What's that mean? Well, clearly that means that we have an elastic curve. Price went up, total revenue went down, price went down, total revenue went up. And if the price went up, then total revenue will go down, right? Sensitive to a change in price, right? Excellent. A great way to think about this, just to make it easier for you, if price goes up and total revenue goes up, both of them going up, those two create an I for inelastic, right? If price goes down and total revenue goes down, those two come together and create an I for inelastic. If they're moving in the same direction, it's inelastic demand. All right. Excellent. Hopefully that made a little bit of sense to you. We're going to stop here, and then we'll pick up in the next one on cross-price elasticity, income elasticity. So we'll have 3 total review videos here. All right.